But so sorry to interrupt that. We just hit the record button, so folks know.
Okay, great.
Thanks.
All right. So, Mary, take it away.
Okay, great. Thanks, Tommy and Gilly and Andy, and thanks to everyone who is online today. Glad you could be here to hear about the 2024-2025 California Current Ecosystem Status Report. Andy and I are excited to present this report on behalf of the California Current IEA team. Before I begin, I'd like to acknowledge the core team members listed here who have been working very hard over the past few months to help pull this report together this year. And I also really want to thank those individuals who contributed data, text, and interpretation of their data to this report this year. As you can see, we had over 90 individuals from over 23 institutions contributing to this report. And we really appreciate you, and we really appreciate your help this year. And we know that you have a lot of other work on your plate. So we're grateful that you were able to help out this year. Next slide. So I'll start by just providing a really brief overview of some of the key takeaways from 2024, and then we'll dive into some of the details around the physical, ecological, and human well-being indicators. So listed on this slide, you can see some of the three top takeaways from this year, that the year started off with a strong El Nino in the winter and spring, which eventually gave way to a delayed but really strong upwelling that helped that led to some really productive coastal conditions throughout much of the remainder of the year. There's also abundant winter and spring snowpack for much of the West, which helped alleviate some severe drought conditions in some regions and also helped improve stream flow. And there was also a diverse and relatively abundant prey community in several regions within the California Current in 2024. Next slide. In terms of some of the unfavorable conditions that we observed in 2024, there was another top 10 marine heat wave, although it largely stayed offshore throughout the year. There was an emerging drought conditions in late 2024. And as we all know, there were some devastating fires in coastal areas in Southern California. There were multiple HAB events that impacted marine life and human health and fisheries in some regions of the California Current. There were also some increasing trends in humpback whale entanglement reports. The California salmon fishery was closed for a second consecutive year in 2024, and there were also declines in landings for many of the harvest groups this in 2024, and most notably was the decline in landings for Pacific whiting. There were also some notable shifts in some of the human well-being metrics for fishing reliant communities, particularly in Oregon and Washington. Next slide. Now, there are also a lot of good mixed to positive signals in 2024. So I mentioned there was that delay in spring upwelling, but eventually in April it resumed, and there were some strong favorable conditions that held the marine heat wave at bay offshore. After the El Nino subsided, many of the zooplankton responded quickly to the strong spring upwelling. Again, there was sort of the abundant and diverse forage base, especially juvenile anchovies and juvenile rockfish and juvenile hake. And this was observed in our surveys and also in top predator diets. There's also a positive outlook for Chinook salmon returning to the Columbia Basin in 2025. And there are better migration conditions for California Chinook salmon smolts as well. And finally, revenue for the commercial fisheries total revenue for commercial fisheries increased by 3% from 2023. And for a second consecutive year, the crab landings were a bright spot. The crab landings and crab revenue were high in 2024. Next slide.
Okay, and then this is on to me. So, yep. Great. Thanks, Barry, for the good, awesome intro. So as I've done in previous years, I'm going to go through what sort of happened in terms of the physical drivers of the system. But this year I've kind of condensed it down into, rather than every month, it'll just be season by season. But hopefully what I'll be doing is bringing in a little bit more connections to some of the biology as well as I go through this. So it seems a little more integrated, hopefully, to everyone. So of course, physically, the big story last year, we all are aware of that winter 23-24 was a pretty strong El Nino. In fact, it was one of the strongest we've had in sort of the modern recorded era. It was, I think, in the top 5. And this is a picture of sea surface temperature anomaly across the entire globe for that winter. And you can clearly see there's this really hot red spots basically all over the place. What did that mean for us here in the California current? This map on the left, again, is the sea surface temperature anomaly from February. And you can see how, unlike if you're familiar with other pictures of sort of heat waves, that El Nino is kind of another kind of heat wave. But in this case, it's all bunched up right along the coast, as you can see very clearly in that picture on the left. What does it mean for the rest of the water column? Well, these pictures on the right are from underwater AUVs, and if you can focus on those 2 little spots that I've circled over the red with a red sort of circle there, you can see that even the subsurface water gets much warmer than it normally would be during these El Nino events. So you have these impacts of the water column. Then also what happens to our upwelling in the spring, or I mean, sorry, in the wintertime, is you'll notice this plot on the right is showing the sort of dark line is showing the upwelling that's happening. And you can see it's much lower during that early winter period there compared to the average, which is the dashed line. So it definitely suppresses the El Nino suppresses the early season upwelling. And the other thing you can notice if you look at the habitat compression index is that the value will be quite low. So that point on the very, very far right there, that's way down below, sort of at 0 there on the map. So that means when that index is 0, it means the habitat is highly compressed. So we get all those features. Biologically, some of the impacts were, for instance, decreased sea lion productivity. So the idea is that there wasn't really much food around for the females during that winter season when they need to prepare for having their pups. Another impact is we had sort of these hangovers of both HABs and other things going on that caused some closures to crab fishery and some delays in some of the crabbing due to whale entanglements. And then, as I just mentioned, why are the crab fishers and things, some of them closed, is often because of HAB. So we had quite a bit of HAB activity from the fall of 23 that kind of bled all the way over into the winter, early season of 2024. And the other part of that goes along that was not only HABs, but also the suppression of upwelling and not much productivity in the really early season led to low zooplankton levels. This may have been, and the impacts of El Nino may have also contributed to a mortality event we had for Cassins auklets, which like to feed on zooplankton. So there just wasn't a good food supply around out there in the sort of late winter, early spring period. But then moving on to spring, things took a nice turn for more positive conditions. This map on the left is just to emphasize that on the top is the sea surface temperature anomaly. And as you go from left to right, it's going through time. And this big green line I put on there is kind of showing that there was just this really rapid transition all up and down the coast in April, where we went from super warm water from the El Nino to suddenly nice cool water. And then on the bottom plot, the anomaly there is the upwelling. So we essentially the opposite. We went from very little upwelling to very strong upwelling. And the result of that was, even though things were delayed a little bit due to the El Nino, we had a very rapid and positive biological response. So this plot on the right is the size of krill. And you'll notice that little point I've emphasized is basically the krill responding to suddenly good upwelling in cold waters led to nice large krill, which is great for everybody to eat. And then the other thing we had is off of Oregon, where they track the sort of large, meaty copepods versus the skinny little nasty southern ones. And we want them to have the nice large fat ones so that things can eat them because they taste good. They're the hamburger copepods. You'll notice here on this plot right after sort of that transition period in April to May, we suddenly have that blue line popping right up, and that means essentially we had the nice influx of all the tasty northern copepods. So very rapid response in the plankton. But some other sort of slightly negative things happened as well in the spring. So we had some pretty widespread domoic acid harmful algal bloom events. Basically April all the way through June, there was an event that led to a lot of dead sea lions. And even though the title of that news article said it was puzzled. People weren't very puzzled, actually. After a little bit, they rapidly realized it was domoic acid. And then we had an outbreak of a different kind of HAB, a PSP, pyrolytic shellfish poisoning due to dinoflagellates, another algae, but a very different kind of algae. And that algae is interesting. When it pops up, it kind of indicates that conditions must have been at some point warmer and slightly more stratified than we would normally see, because that's kind of a precursor indicator for this kind of HAB event. So we had these two HAB events. And we also had in the spring, this was falling right on the heels of this brown pelican starvation event, which again may have been related to too much stratification, and that in turn leads to some low prey availability for those pelicans. So even though things kind of popped back for us in a good way in the spring, there was still some losers out there in the system. Moving on to summer, the point here is that, again, after the El Nino kind of went away, we had very, very strong and consistent upwelling. So this plot on the top, if you'll notice the dark line sort of in the middle of the section there, that's just huge peaks, you can see how much farther above the sort of average level, the blue dashed line, that black line actually is. So we had really strong upwelling. In fact, it's more than the sort of standard deviation as that gray cloud there. And you'll notice the map on the bottom is showing sea surface temperature anomaly. So you'll notice that there is this big red zone. It's a marine heat wave, but it's all offshore. And if you can see it right up along the coast, things were still nice and cool and productive. So that's good. And as we move on through looking at, what are some of the impacts of this strong productive water? Well, it was good in that it, again, got our krill not only large, as I said before, but we're back to sort of average levels. And again, through the summer, we had really nice, good abundance of those, a high abundance of the good copepods, the hamburger copepods, the northern copepods, the ones that are full of lipids that all of the fish and other things like to eat. That's this plot on the bottom there. And finally, we also know from as Mary alluded to in the intro, we know that there was a good amount of other small pelagics out there to serve as a food source. So we were finding anchovy, mackerel, and herring all throughout the California current. So there was also some other things going on physically. There was, however, some hypoxia, but it was this year limited to such a fairly small region for a shorter period of time. So somewhere in middle June, there was some hypoxia just off the sort of southern Washington, northern Oregon coast, but it was sort of limited as compared to some other years. So that's a good thing. But we did have some continued HAB activity. So up off of Oregon and Northern California, domoic acid presence caused the closure of some of the mussels and razor clam fisheries. And we did have, again, continued stranding events of sea lions and common dolphins in Southern California. So there was some negative impacts, even though there was mostly good physical conditions. And then finishing up going into the fall, this has now sort of become the typical pattern where in the fall, the offshore heat waves, once the upwelling kind of decreases, the heat waves will reach the coast. As you can see in this top picture, you can see that heat wave coming right up to sort of Central California. And also, even though we had a little bit of rainfall earlier in the sort of late summer, as we headed into the spring, headed into fall, things were starting to dry out. And so we had a sort of return to some somewhat drought conditions, as you can see in this map on the bottom. However, fortunately, as we went into the fall, the heat wave impacts were kind of limited, and you can see this transition from September to November, where even though we had the heat wave around the coast, the heat wave kind of dissipated and kind of went more to the southwest, which is good. So our coastal waters, even in the fall, return back to sort of average conditions. And we had a nice batch of precipitation come into the Pacific Northwest. There was a couple of atmospheric rivers that came through. So you'll notice this map on the right, as we went from October into November, you'll see all the green there. So those are regions that had plenty of precipitation. However, as noted earlier, you'll see in the Southwest region, it got just even drier and drier, and that helped contribute to those big fires we had. And then I'll pass it back to Mary.
Okay, great. Thanks, Andy. So now I'm going to provide some information on the ecological conditions in the California current in 2024, and then I will move into providing an update on the human activities and human well-being indicators in 2024 as well. So go ahead. Next slide, Andy. So to start, I'll present some information on the forage community in the northern region of the California current. This figure in the middle shown on the slide shows the results of a cluster analysis that was applied to data from the Northwest Fisheries Science Center's Juvenile Salmon and Ocean Ecosystem Survey, or JSOS for short, which took place last June. The cluster analyses help us identify shifts in forage conditions over time, and the colors indicate the relative catch per unit effort, where blue indicates the forage species was abundant, red indicates that they were rare, and gray indicates that they were close to their average abundance. The horizontal bars separate clusters of the typically co-occurring species, and the vertical bars represent breaks in the assemblage structure between years. So overall, the results of this analysis indicate that the forage community composition in the Northern California current in 2024 was relatively similar to the previous year. The figure also indicates that in 2024, the community was characterized by a high abundance of yearling coho salmon and juvenile chum salmon and various jellies. However, the community was also characterized by a low to near average abundance of yearling Chinook and juvenile sockeye salmon, and a drop in the abundance of market squid and juvenile sablefish from the previous year. This decrease in the abundance of sablefish in the JSOS survey aligns with sablefish catch data from the West Coast Groundfish Bottom Trawl Survey and the juvenile biomass index that's estimated from the trawl data. And as we can see in the figure on the right, the juvenile abundance index also shows or suggests a decline in the recruitment of sablefish in 2024 from the previous year. Next slide, please. Also of note was the high prevalence of juvenile rockfish and juvenile sardine in the JSOS survey. Rockfish and sardine are collected but not sampled quantitatively by the JSOS surface trawl and are noted in terms of their relative prevalence instead. So, for example, the proportion of stations where they're caught. In addition, during a fishermen and scientists roundtable that was held in Newport in November, Oregon fishermen noted the market basket feeding pattern of predators, or in other words, sort of the high diversity of forage during the summer and early fall in 2024. And this aligns with the surveys as well, and indicates that prey availability was generally high in this region over the past year. Next slide, please. Okay, so the next slide shows the cluster analysis of the forage community in the Central California current, which is based on data from the core area of the Southwest Fisheries Science Center's Rockfish Recruitment and Ecosystem Assessment Survey. The cluster analysis here indicates that the forage assemblage in the central region of the California current has also been relatively consistent over the past few years. This region was characterized by a high abundance of ectophids, and juvenile stages of rockfishes, anchovy, sardine, and Pacific hake. In the time series figure shown on the right, the blue shaded area shows the most recent 5 years of data. The dashed line is the long-term mean, and the blue lines indicate +1 standard deviation of the mean. And so what we can see from these time series is that the catches of juvenile anchovy and rockfishes were at their highest abundance relative to the past several years, and the abundance of juvenile hake and rockfish show an increasing trend over the past 5 years as well. Also of note is the decline of the abundance of adult anchovy, adult sardine, and market squid in 2024, which is shown in the figure of the cluster analysis. Next slide, please. In the Southern California current, the forage assemblage that is sampled through the Cal Coffee program has been strongly consistent since 2017. In 2024, this region was once again characterized by high abundances of larval anchovy and mesopelagic California smooth tongue. Larval abundances of rockfishes, Pacific hake, as well as Pacific mackerel and jack mackerel were also very high in 2024. And notably, the larval hake abundance in 2024 was the highest in the time series, which is shown in that figure on the bottom right. In contrast, the abundance of larval sardine and market squid remained below average in 2024. Next slide. The decline in the abundance of adult anchovy that was observed in the Central California current through the Rockfish Ecosystem Assessment Survey was also observed during the Southwest Fisheries Science Center's Coastal Pelagic Survey. The biomass of adult anchovy is shown in the figure on the left in green. And this figure also indicates that other coastal pelagic species, such as Pacific herring and sardine, were relatively similar to the past few years. The map on the right indicates that in 2024, northern anchovy comprised most of the samples south of San Francisco, while jack mackerel combined most of the samples between San Francisco and Newport, Oregon, and Pacific herring comprised most of the samples from northern Oregon, Washington, and Vancouver Island. Next slide, please. So this new map on the right shows samples from nearshore waters, so those that are less than 5 nautical miles from shore, and shows that Pacific sardine were caught primarily in the nearshore area, with sardine from the northern stock caught off Monterey Bay in San Francisco, and those from the southern stock caught south of Point Conception. Next slide, please. I apologize for the delay. The transition is really slow on my computer. So the diets of highly migratory species and seabirds that were collected by commercial and recreational fishermen and other partners along the West Coast indicate that predators were capitalizing on the abundant and diverse prey items in the ecosystem over the last 2 years. For example, sardine, anchovy, and Pacific hake dominated the diets of albacore tuna, bluefin tuna, and swordfish in 2023. There were also lots of myctophids and pyrosomes observed in bluefin diets, which align with what was seen in the Rockfish Recruitment and Ecosystem Assessment Survey in the Central California, as well as the Cal Coffee surveys. We also saw an increasing trend in juvenile rockfishes consumed by common mirrors at Yaquina Head in Oregon, again, which aligns with the high prevalence of rockfish observed in this region by the JSO survey. And in addition, most of the piscivorous birds at Southeast Fairlawn Island in Central California relied more on juvenile rockfish and less on anchovy for the first time in several years. For example, the figures on the bottom right show the high consumption of juvenile rockfish by Brandt's cormorant in 2024, with a concurrent decline in anchovy in the cormorant's diets. And again, this could reflect the observed increase in juvenile rockfishes and decline in adult anchovies in those surveys in the Central California current and from the coastal pelagic surveys as well in 2024. Next slide, please. So despite the good foraging conditions, fledgling production in 2024 decreased to below average levels at most the seabird colonies in Oregon and Washington. In Central California, productivity was good for most of the monitored species in 2024. One exception was the productivity of Brandt's cormorant, which declined to well below average. This could be attributed to poor local prey conditions associated with El Nino during the winter and early spring. Which could have led to poor adult condition during the breeding period and therefore poor breeding success. Next slide. So in the next 2 slides, I'm going to shift away from talking about the forage community to highlighting updates to the salmon stoplight tables. This slide shows the Northern California current stoplight table, which summarizes many physical and biological indicators that support qualitative outlooks of Chinook salmon returns to Bonneville Dam and smolt to adult survival of Oregon coast coho salmon. The colors in this table represent a given year's indicator relative to a reference period. For this table, the reference period is 1998 to 2020, although I truncated the figure for this presentation to 2010. The green and blue colors represent indicators that are greater than 1 standard deviation or 2 standard deviations above the mean. Orange and red represent indicators that are greater than 1 standard deviation or greater than 2 standard deviations below the mean. And yellow means the indicators are within plus or minus 1 standard deviation of the mean. The blue arrows and the box are highlighting that Chinook salmon from smolt year 2023 and coho salmon from smolt year 2024 represent the dominant age classes returning to the Columbia Basin in 2025. In looking at this table, we see that in 2024, most of the physical and biological indicators are yellow or near average, or orange or below average, which suggests that juvenile salmon experienced poor to moderate ocean conditions this past year. The strong El Nino combined with above average temperatures and low larval fish biomass suggest less favorable ocean conditions for juvenile salmon. However, some indicators such as the northern copepod biomass and PDO indices are consistent with productive conditions that are typically favorable for salmon. So overall, the ocean conditions in 2024 suggest average survival for coho salmon returning in 2025, and the conditions in 2023, which reflect a mix of good and intermediate conditions, suggest average returns for Chinook in 2025. And in addition, a quantitative model developed by Brian Burke at the Northwest Fisheries Science Center that uses these stoplight indicators predicts the average counts that the average counts for Chinook salmon returning to the Columbia Basin in 2025 will be above the 10-year average. Next slide. The stoplight tables shown here were developed for 3 California salmon stocks, including Sacramento River Fall Chinook, Central Valley Spring Chinook, and Klamath River Fall Chinook. The time series go back to the 1980s in the ESR, the Ecosystem Status Report, but I truncated them for this presentation. The color coding in this table is similar to that what I just showed for the stoplight tables in the previous slide. The blue box here highlights Chinook salmon from brood years 2022 and 2023 that migrated to the ocean in the following year, and are also the dominant age classes returning to the California rivers in 2025 and 2026. So indicators for the 2022 and 2023 indicators suggest improved habitat conditions for Central Valley Spring Chinook and Sacramento River Fall Chinook. The incubation temperatures, outmigration temperatures, and outmigration flows improved compared to the 2020 and 2021 brood years. The indicators for Klamath River Fall Chinook improved slightly for the recent brood years, but were still mixed. So for example, the sea surface temperatures and the North Pacific Index have been average for the past 5 brood years, while outmigration and incubation temperatures have been average to below average over the same time. Stu Munch and Corey Green at the Northwest Fisheries Science Center are leading an effort to produce indicator-based outlooks 2 years in advance of adult returns based on the indicators in the stoplight table. And their preliminary outlooks suggest moderate returns of Sacramento River Fall and Central Valley Spring Chinook in 2025, with some slight improvements in 2026. In contrast, the indicator-based outlooks for Klamath River Fall Chinook suggest low returns in 2025 with some slight improvements in 2026. However, there's uncertainty over how the removal of the Klamath River dams have impacted salmon, but we should be able to, the effects of the dam removals should become apparent in 2027. Next slide. The final piece of ecological information that I'll highlight is on whale entanglements. Based on preliminary data, the confirmed West Coast entanglement reports in 2024 were below the peak years of 2015 to 2018 and slightly higher than those in 2023. A combination of the habitat compression that Andy mentioned, as well as high forage levels in nearshore areas, was likely a culprit for the heightened whale entanglement this past year. Humpback whales continue to be the most common species reported, and confirmed entanglements increased for humpbacks in 2024, whereas entanglements decreased for gray whales and killer whales. Next slide. The whale entanglement risk impacted the Dungeness crab fishery on the West Coast. The figure on the right shows the spatial temporal history of closures and management restrictions in the Dungeness crab fishery from 2020 to 2024 due to whale entanglements, domoic acid, and other concerns. You saw this figure earlier when Andy pointed this out. The solid black lines indicate state borders, and the dashed lines indicate the border between the Northern and Central California management zones. And the gray shading indicates the commercial Dungeness crab fishing season in each region. And so what we can see from this figure is that in 2024, if we just kind of focus on those blue shaded areas, we see that there were fishery closures in Central California due to whale entanglements. And in Northern California, Oregon, and Washington, gear reductions and depth reductions were implemented to reduce the risk of whale entanglements in those regions as well. Next slide. So now I'm going to present a few highlights from the ecosystem status report with respect to human activities and human well-being. Next slide. In 2024, total coastwide fisheries landings declined by 12% from 2023 and declined to well below average. This was largely driven by the decrease in Pacific whiting landings, which declined by 31% from 2023. Landings for coastal pelagic species and highly migratory species have been low over the past several years, and the salmon fishery was closed in California for a second consecutive year in 2024 due to low returns. Some bright spots in 2024 include the high landings for crab and increased landings for market squid and shrimp. We don't show the time series for recreational landings here. However, we note that the coastwide recreational landings declined in 2024 to below the long-term average, and we're actually among the lowest in the time series, which I believe started around 2005. Next slide. The total coastwide fisheries revenue increased by 3% in 2024, which was driven by the increased revenue for market squid. The total revenue remained within one standard deviation of the long-term average in 2024. Crab revenue remained high in 2024, whereas revenue for other harvest groups, including non-whiting groundfish, coastal pelagic species, salmon, and highly migratory species, remained greater than one standard deviation below their long-term averages. Next slide. The CCI team has been developing several measures and updating these measures of human well-being over the past several years. And I'll highlight a few of them today, starting with fishery diversification. So as a reminder, the idea here is that diversifying fishing across multiple fisheries or regions could increase revenue and reduce variability in revenue, and possibly buffer vessel owners from shocks to the fishery. The CCIA team has been measuring multiple types of fishery diversification, including revenue diversification, which is shown here. Revenue diversification measures how revenue is spread across species groups. So the figure on the right shows that in general, revenue diversification has been declining for West Coast fishing vessels since the mid-1990s, and also shows that California, Oregon, and Washington fleets saw decreases in diversification in 2023 relative to 2022. And this sort of decrease can potentially pose more risk to the vessel owners. I do want to note that this figure shows the average trend in the revenue diversification, and that there are wide ranges of diversification levels and strategies, and some levels do remain highly diversified. You can find more information about other types of diversification in the appendix of the ESR. Next slide. The CCI team has updated the community social vulnerability scores for commercial and recreational fisheries for communities in 5 regions, including Washington, Oregon, and Northern, Central, and Southern California. The plots shown here for Washington and Oregon, these are for Washington, Oregon, commercial and recreational fisheries, but in general, the figures that I'm going to show are based on the most recent available data, which is 2022, and include the 5 highest scoring communities for commercial and recreational fishing per capita engagement for each region. And to help you interpret these plots, the communities in the upper right quadrant are the plots shown here, and on the next slides are those communities with relatively high social vulnerability and either high commercial fishing per capita engagement, for those on the left, or high recreational fishing per capita engagement for those on the right. And just to provide a little bit more information on these indices shown here, that the social vulnerability indices shown on the y-axis are derived from social data and communities that depend upon commercial and recreational fishing. And these data include demographics, personal disruption, poverty, housing characteristics, and housing disruption. The commercial fishing per capita engagement indices shown on the x-axis in the figure on the left are based on analysis of factors that reflect commercial fishing, like fishery landings, revenues, permits, and processing. And the recreational fishing per capita engagement indices in the figures on the right are based on analysis of variables relevant to recreational fishing, including guide and charter permits, recreational retail shops, and marinas. So overall, the analysis indicates that the fishing community vulnerability is higher in Washington and Oregon than in California. The figure on the left shows that Tokeland, Washington and Westport, Washington had high commercial per capita engagement and high social vulnerability in 2022. The figures on the right show that multiple communities with relatively high recreational per capita engagement also had relatively high social vulnerability scores. Overall, Westport, Washington, Winchester Bay, Oregon, and Garibaldi, Oregon were among the most reliant on both commercial and recreational fishing. Oh, sorry. My slide didn't change. Did you change slides?
No, Mary, I'm sorry. Did you want it the
Okay.
next slide? Or?
Yes, please. Yeah, please
Okay.
switch to the next slide.
Oh, okay. There you go. Sorry. We also, in addition to sort of showing the data from 2022, we also provided comparisons of community social vulnerability scores between 2021 and 2022, which indicate that social vulnerability increased in Winchester Bay, Oregon, Hebo, Oregon, and Westport, Washington in 2022 relative to the previous year. Next slide. So here are the community social vulnerability scores for California. And overall, these figures in comparison to those on the previous slide, again, indicate that in 2022, fishing per capita engagement in California was lower than in Oregon and Washington. The figures on the right indicate that Bethel Island in Central California had high recreational per capita engagement and high social vulnerability. And looking across all figures, we see that Crescent City, Fort Bragg, Trinidad, Bodega Bay, and Avalon were among the most reliant on both commercial and recreational fishing. Next slide, please. Okay, so lastly, I want to mention that the CCIE team has also updated the fisheries participation networks for IOPAC port groups on the West Coast. These networks provide information on economically important commercial fisheries for different ports, and they are valuable for tracking how the number of fisheries in the port groups and the connectivity between fisheries and individual port groups have changed over time. And one take home in this year's report is that in many port groups, they experienced declines in the number of fisheries that vessels participated in, and in some port groups also had less connectivity between the fisheries. And this is important because reductions in connectivity could in turn reduce the resilience of the fishers and fishing vessels to environmental and market pressures. Next slide. Okay, great. Thanks, Mary. This is back to me. I'm just going to give you a brief overview of what we might be expecting as we head into 2026 in terms of our some of the indices that we have some physical measurements for and some model forecasts for. So just to touch back on where we are currently for our large sort of climate indicators, these are the three big ones. That sort of teal line is the basically an indicator of El Nino. Then we have the green line, which is the Pacific Decadal Oscillation Index, the PDO, and we have the red line, which is the NPGO, the North Pacific Gyre Oscillation. So what these tend to indicate is the teal line is saying, yes, we had a large El Nino back in January 2024, as we all are aware of. But you'll notice that line like slowly dips down and becomes below zero, which means we're heading back towards either a neutral or even a La Nina state. The other two indicators, the red one, unfortunately, we don't have up-to-date data on, but the green one with the PDO, you can notice that it was sort of down of a negative value for a while there in the summer and fall, but it's heading back up towards a sort of neutral value as well. Unfortunately, when these indicators are all sort of in their neutral state, it doesn't give us as much to hang our hat on as when they're either strongly positive or strongly negative. So we're sort of in a little bit of a sort of neutral state, which makes it a little bit harder to make these predictions for the future. And the same thing can be said is true for the official CPC. And so probabilities as we go on through the year. So this is again a ensemble model forecasts looking at the probability of having either a El Nino or a La Nina or neutral conditions. And you'll notice the sort of gray bars, neutral being the highest ones here as we forecast through the season. But we've also got the blue bars, which is La Nina. So we've got sort of 50-50, 50-40, 50-30 sort of chance between either neutral or La Nina season climate forcing as we proceed into 2025. I'm sorry, 2026. Actually, I realize if he's saying 2026, we mean 2025. Excuse me. I'm sorry. These are mislabeled. So here's our drought outlook for as we head into 2025. You'll notice that it's looking like we'll have persistent drought in the sort of southwest region, but no drought forecast for the sort of central to northern region. As we look at the marine heat wave going ahead, this is the current conditions, the most latest snap of sea surface temperature. You'll notice that the coastline and within the EEZ, which is marked off with the little sort of blue dashed lines, it's still sort of neutral to cooler than normal, but we have a little bit of unusual condition. Typically by this time of the year, the heat waves are in the open part of the ocean are mostly dissipated, but instead we have sort of this blob of fairly warm water to the far sort of central southwest portion of this map, and we have sort of the zone that's typically starts getting warm in the sort of northwest region there off of Alaska is still warm. So that's a little bit unusual, but fortunately it's all offshore at this point. As we look for the marine heat wave forecast, you'll notice as we go further into the year, on the top, we're looking at the probability of marine heat waves. It's sort of the typical story that we see with offshore heat waves during the spring and summer, with a potential, as you can see in October, of potential of it coming into the coast. Again, this seems to be the typical pattern we're seeing year after year now. We also have some forecast modeling from the JScope group provided by Sam Seidlecki and Isaac Kaplan. And this is a computer simulation that basically is telling us what we might expect for several different properties we go forward into next year. And you'll notice that this one is the integrated chlorophyll, and this is telling us the anomaly of chlorophyll. So what this is saying is that in the early part of the year, we might expect more chlorophyll than normal, but that as we, or I'm sorry, higher chlorophyll than normal, but as we go on into the summer, it's much lower than normal. Unfortunately, the uncertainty is fairly high due to unknown variability in the wind forcing as we go on into the year. So you have to take these forecasts with a slight grain of salt. Same thing can be said for the oxygen. Again, a lot of this is because we're in this sort of neutral conditions for ENSO, which is our major climate driver. And when it is neutral, it's a little bit more difficult to rely on some of these forward forecasts. But if we take that with a grain of salt, we can still look at these maps and see that the bottom oxygen will be is forecast to be lower over both the Washington, Oregon shelves, and hypoxia may come in earlier this year than usual. And that's all for the forecast, and I'll hand it back to Mary to finish this up here.
Thanks, Andy. Yeah, I'll just run through hopefully some of the conclusions from the report. So as we have presented today, the El Nino did have some impacts on the California current, but the ecological response was a bit more muted compared to similar past events. There was delayed productivity, but that was compensated by some really strong upwelling in April. There were also multiple HAP events, which led to some delays and closures in fisheries, particularly the shellfish fisheries. And both the delayed productivity early in the year and the HAB events did have some impacts on the bird and marine mammal populations in the system. Next slide, please. Okay. The California current again shows some resilience to that strong El Nino earlier in the year, which was fueled by some strong upwelling and productivity. There were again diverse and fairly abundant forage base to help support the predators. Some species did better than we had expected. So, for example, krill off Central California are usually are low in abundance during an El Nino, but this past year they were actually around sort of their average abundance levels. There's also improved habitat conditions and positive outlooks for some of the salmon, Chinook salmon in the California rivers and the Columbia Basin. Some of the species that have been doing well and have been on the rise over the past few years include juvenile or young of year rockfish, anchovy, and young of year Pacific hake. Again, that larval abundance of Pacific hake had reached its highest abundance this year as well. Another bright spot, as we mentioned, were the high landings of crab and revenue in 2024. Next slide. So while there were some or many positive signals in 2024, there are also some indicators that raise concern. As Andy has talked about, there was a large marine heat wave offshore that sometimes encroached on the coast, and we're expecting a marine heat wave, an offshore marine heat wave in 2025. And as we know, these heat waves can impact the coastal system, can lead to increases in whale entanglements and mortalities of top predators. Again, there were some declines of fisheries landings in many of the harvest groups, and the California salmon fishery was closed again in 2024. We also saw that there were increases in social vulnerability in some of the fishing communities in Oregon and Washington, and also in some of the IOPAC port groups. There were also reductions in the number of fisheries that vessels participated in. In some of those ports, there's also less connectivity between the fisheries. And again, these changes in the human well-being indicators could potentially reduce the resilience of fishing vessels and coastal communities to fishery shocks or environmental and market pressures. Next slide, please. So finally, we just wanted to mention that the CCIE team is continually seeking new ways to support climate-ready and ecosystem-based decision-making for the California current. Some of the new research and activities related to the ESR that are under development include the use of eDNA data that are collected from our surveys to provide information on species distribution and abundance in different regions of the California current. The CCIE team is also working to develop short reports of indicators from the ecosystem status report that are tailored to specific stocks or FMPs to help support the updates and developments of new risk tables. We're also interested in including more information from fishermen in the ecosystem status report. And one way we have sort of piloted one way to do this was through a fishermen and scientists roundtable in Newport, Oregon this past fall. And we held this roundtable in partnership with ODF&W and an Oregon Sea Grant. And through this roundtable, we're able to exchange information with fishermen and also try to co-develop knowledge for the ecosystem status report, and really try to bring in more on-the-water observations from the fishermen, particularly for those times of years that we can't be out there surveying. So we really enjoyed that first roundtable, and we're hoping to continue doing that, and also trying to expand that to Washington and California at some point as well. Next slide. So with that, I just want to thank you all again for listening in today. And I also, again, want to thank the core team members as well as this full list of contributors here for doing such a great job and helping us pull together this report this year. And so with that, I think we'd be happy to take questions from the group.
Great. Thanks for that, Mary and Andrew. And I guess, Gilly, did you want to stop the recording?
Oh, thank you, Tommy. I was going to record the Q&A session as well. Yes.
Okay,
if that's
great.
all right. Great. And then we'll hit stop just after that.
Sounds good. So I have plenty of questions, but I will bide my time a bit. In the chat, there were a few on the social indicators side, which I think is where Gary's hand just came up for. And it's on some of the ports or locations listed. So before we go to Gary, I'm not sure if either of you know, like for the social indicators in the specific ports or locations, do you know how those locations are determined? I know we've had this, I know we talked about this in the past. I think it was based on either census data or zip code data. But
yes, it is. It's based on census data. And I actually was going to ask Amanda Phillips, who's been helping us out this year on the human well-being, human dimension section, if she wants to come on and address the question.
yeah, please go ahead, Amanda. Maybe. Looks like your microphone's not working. You're showing up as unmuted on my end, but we're not hearing anything.
Is it working now?
There you are.
Great. Thanks so much. Sorry about those technical difficulties. Yeah, I'm happy to talk about how those ports are chosen. It's a couple of different factors that go into it, including for commercial landings, it's the amount of commercial landings in a port, the number of permits held in a port, number of processors in a port, and a few other fisheries-based metrics. And then it's the top 5 ports for each region that are shown on the figure. There are all ports with any fishing landings are calculated and shown, like measured against each other to get that top 5. And those are just what show up in the figure.
Thank you. Go ahead, Gary.
Yes, hi. So if I'm understanding what's being discussed, has Pillar Point been considered and decided that the catches are not high enough for both recreational and commercial?
It might. I'm not sure exactly if Pillar Point has been considered in the past. It might be more of a labeling issue about how those places are designated and those fishery groups are, that fishery information is assigned to different regions.
Okay. Well, my
And
request is I
sorry.
represent the San Francisco region. I live in the area and fish out of Pillar Point at least weekly, if not multiple times a week. And as Captain Smitty has input here in the comment section, we've seen dramatic declines of many of the fisheries as well as crab this year. And so if it's possible to consider adding Pillar Point, if it's not already being considered, that would be my request.
Right, thanks, Gary. Go ahead, Scott.
Great, thank you. Good morning, and thanks for the report. I have a question about the changes in fisheries diversity, and it's going down. I'm just curious if there's any evidence to indicate that that means that boats are fishing less, or are they becoming more targeted in a given year on a particular fishery that's either available or more lucrative?
That's a good question, Scott, and I can try to answer that, or at least take a stab at answering it, and others on the call who might be more familiar with this could chime in as well. I remember last year we showed both a revenue diversification and a livelihood diversification. And so some of those sort of two indices, if you looked at them together, indicated that there was a shift in some regions, some of the states, towards communities that were getting less of their income from fishing and moving into sort of getting income from elsewhere. So there could be some of that. We could be seeing some of that in this decline as well. But that was from, we didn't show that here, but we have it from last year's report, and that kind of information is updated every couple of years.
Great, thank you.
I think Jamil might chime in here as well. Go ahead, Jamil.
Hi, Mary. Yeah, thanks for the question, Scott. I'll just add that, it depends how you would define fishing less, but as Mary and Andy presented, both landings and revenue are down at a coast-wide level across all fisheries. So there is less landings and revenue happening, with the exception of market squid. And in the Fisheries Participation Network analyses that are included in the ESR, we show that in many port groups, there are fewer fisheries that are generating substantial amounts of revenue. And so there is evidence that there's a decline in the number of fisheries that vessels are participating in, which would imply that there's more targeting or specialization to your initial question. Thanks a lot.
Great, thanks. Go ahead, John.
Yeah, I was just curious. It seems like we're getting or seeing a lot more publications and attention to the impacts of the odd year pink salmon dominance, specifically in the North Pacific. But I noticed in some of your graphs, you see some shifts, every other year cycle shifts, especially in like anchovies, to even year abundance and odd year abundance that may be tied to that cycle. Is that playing into any of the stuff you guys are working on? Or are you paying attention to how those odd year dominant pink runs might be in fact impacting some of this stuff?
That is not something that we have been looking into. There was a seabird ecologist who had contributed this report who had brought up the pink salmon in the odd years and even years, but we haven't dug into that much more in this report. But we could certainly take note of that and take a closer look at it for sure. Thank you.
All right, well, seeing the hands slowing down, I can move into my question. I guess this is on the skipper science or the observations. I just advocate for expanding that and finding ways for getting more, especially like qualitative observations. I know speaking with fishermen out of Nia Bay in Northwest Washington who fishes on the Strait of Juan de Fuca, over the summer, krill abundances up there were highest he's seen in years to decades probably, where on some days it looked like it was raining because there was so much activity at the surface. And this fall, or I guess it's midwinter or so, he had also observed really high midwater temperatures off the coast there that he wanted to flag. So it didn't really show up in satellite, but my thought is as we switched downwelling, we were just pulling some of that warmer offshore water near shore, and not enough storms yet to fully disperse that. And I'll take Andrew's nodding as agreement.
Yes, we can hear you.
Go ahead, Yvonne.
Me? Hello. Okay, thank you. So first, I wanted to thank folks for, well, first, thank you for the presentation in general. I really appreciate you doing this before the council meeting because it kind of gives me personally a kick to start reading some of this stuff beforehand and thinking about it. And I wanted to just note for folks on the call, I think that every year we have some comments on one variety or another, totally understandable, that this or this or that port name is not the port name that I had expected, or where does this come from, and we don't see landings into this place and there's more in that place, and all completely reasonable comments and things that we need to track. Unfortunately, the place names that are in the databases or that are provided by the data managers are maybe not always the same place names that link up with what sort of regular people living in those places think about. So it's an ongoing challenge, and I suspect that we'll just have to clean it up over time. And by that I mean if it says something, if it's called Pillar Point in the database, but it really means San Francisco, then we need to sort of remember that for future years. But so just a general thought on that. And then I had a bunch of smaller comments. Let's see, that I wanted to mention. For the salmon folks who are on the call, it was kind of interesting to me that we're seeing maybe possibility of improved conditions for 2025-26. And I want to be tracking that and thinking about that over time, because it'll be interesting to see how that comes out, as we actually proceed through those years. I was really interested to read about the anchovy, that there were some more pelagic species that were eating a lot of anchovy. But then, if I remember correctly, I think brown pelican is almost exclusively anchovy. And so it was kind of, no? Okay, I see Andy shaking his head. But I was surprised to see their numbers decline when everybody else seems to be eating a lot of anchovy. So if there's anyone bird oriented on the call, I would be curious to hear about that. This is a very minor comment and may only be applicable to me, but on page 25 of the document, there's a figure 3.11. And it looks super interesting, but it's very difficult to see. And so I'm not sure that and maybe this is just me, maybe are you conveying the information that you hope you're conveying? Because I find it difficult to see the color gradations on those teeny tiny graphs, but I bet it would look awesome on screen. And then also a specific thing, figure 4.3 and EWG, I'll make notes of this in our doc so we can add it to our report or not. But figure 4.3, so which is fisheries participation networks for example, IOPAC port groups. This is awesome. And I wonder if we could have something like this on the council website, but expanded to more ports. It would be great. And I realize I'm creating work here. If there were a way to hover over a port and get an idea of what are the major species that each port area is dependent on, because I think one of the challenges the council has had over the years, I'm thinking of they deal with salmon on a Tuesday and then groundfish on a Wednesday, and they don't always necessarily remember that the decisions that they made on Tuesday are negatively affecting the same ports that maybe are also affected by the decisions that they're making on Wednesday. Does that make sense? So it would be great if council members and advisory body members had an easy way of looking at all the ports and just double checking, okay, decisions that we're about to make are going to have negative/positive effects on this or that port. I just want to check and see which port it is that's going to be most or least likely to be affected by some of these decisions. So I'd appreciate some EWG discussion on that particular question, because I think it could be interesting to future council discussions. And then lastly, in Yvonne's list of random thoughts, page 61, table D2, which is predicted and observed environmental and biological conditions in the CCE impacts during 2024. This is really interesting, and I really appreciated this table because we don't do a lot of, it feels like to me, but maybe I'm just ignorant, a lot of looks back at whether and how our predictions worked out. So I was like, oh, this is so awesome to see something and say, oh, okay, yeah, actually we did pretty well on these things, and maybe we were off on these things a bit, but there's not any red in that table. So that was great. That was very reassuring to see that we didn't have things where we said, and maybe it'll change in future years, but thank you for doing this. Really loved it. And if you had it last year, I apologize for missing it. That's my litany for now. Thanks.
Yvonne, if I could just respond to your comment on that table. The thing is, it's a lot easier to make those kind of predictions when we know when we made those predictions, we knew a strong El Nino was coming. So as I kind of mentioned during the talk, when we know it's either a strong El Nino or a strong La Nina coming soon, it's a lot easier to make those predictions. It's much more difficult. So for instance, this year we're going into now, it's much more difficult to make those kind of predictions when we're in a sort of neutral kind of wavering state with those big climate drivers, which is unfortunately how we are right now. So I don't think we'll make those kind of tables every year when we don't have that kind of strong climate signal leading into it. But last year it was a great year for doing that, because we had that. We were very, very certain that a strong El Nino was coming, and that's what we got. So it was easier to make those kind of predictions. But yeah, and I think again, it was a big effort on our whole team that we came together in December before the meeting that year to talk about what people's predictions were for the El Nino coming on. So that was a true sort of group effort to put that together. And I thank all the team members that participated in that exercise.
Thanks, Andy. I think that's a great reminder of, like, we're always trying to ask ourselves, like, what are the conditions that make our predictions or forecasts easier or harder? And sometimes it's just that the system is sending you like a really clear signal, and it's not because you're more fabulous than you were in years past. Thanks.
Yeah, great stuff, Yvonne, and glad to see that folks are taking the time to read the whole thing. It's definitely a good way to keep up to date. The beginning of each section, there was a summary of the key, like the highlights for, sorry, go switch tabs here. For each of the subsections, there's a key message. There we go, get my lingo right. I don't know if it'd be feasible or how much extra work would be to maybe pull those together into, after your infographic at the beginning, as just an executive summary. And I like interactive documents, so it also, if those are pulled together as some type of summary, they could also be linked within the document, so you can just click on them and jump to a section. And thinking of like future iterations as well, like just more links to the IEA's website and where some of these things, so that we can jump out of the PDF to the website and go explore the data. Just for largely for folks who don't, just sit around looking at data on their own, which I don't know why people don't do more of that, but I enjoy it. Just a couple thoughts just for ease of use. At least from my end, it's probably a lot more work for you, for, a bit of convenience for me, but yeah. Go ahead, Mary.
Yeah, thanks for those great comments, Tommy. I just wanted to mention that you are spot on. the ESR team has been talking about pulling out those key messages and summarizing them at the top or somewhere within the document and elsewhere. So that's something that we're planning to do or hoping to do. And also, I did not mention this while I was presenting, but if you look at some of those slides, there was that QR code of the interactive infographic. And if you click on that and you kind of play around with the infographic, when you highlight sort of like the different data streams that went into that infographic, it will take you to the actual data for those indicators. So that is kind of built into the report, but it might not be as apparent. So you should probably highlight that a little bit more.
And could I add on to Mary's response, Tommy, to your comments? I think if we got additional, if most people are saying yes, we like those key messages, pull them out, and depending on how we package them in the report, I would just ask that maybe we can ask for a little more leeway on our word count. So remember, we have a sort of hard word count that we agreed to for the report. And when we start repeating, even though I agree, I think it's super helpful to have those key messages pulled out, but it ends up being like we're repeating some text, and we kind of end up wordsmithing and counting every little word we have on there. So maybe we can work out a deal if we get enough folks saying yes, we really like this. Maybe we can get an additional, a couple hundred words added in. I know it doesn't seem like much, but when we wordsmith every word to fit it into our sort of guidelines for how much, we don't want to lengthen the report out. Yes, stay within our word count. Yes. So I would just ask, maybe we can make a deal. So thank you.
I guess as an alternative as well, maybe it could be a separate 2-3 page document. That way you can cheat your word count by, having different documents. And I would definitely advocate for more words, but or word count being a loose target rather than a hard cut. All right. I am quite happy to ramble on here if folks don't have questions. Otherwise, we can also start to wind this part of the call down. Just wait to see if there's more hands. Andrew and Mary, are you both going to be at the March Council meeting?
Yes, we'll both be there next Wednesday through Friday. Yep.
Would it be wrong of me to volunteer you guys to encourage folks to talk to you about it in between your various tours around the advisory bodies?
No, we would love to talk with people about it. That would be great.
Perfect. One thing I was thinking of is a discussion we've had in the SSC was around, there used to be kind of the evening, or they call them like fireside chats, of kind of an evening get together where it's a informal discussion. I don't know if we have time to plot anything. I guess if it's informal, we don't have to plan anything because it's informal, but something to chew on while folks are there. Go ahead, Corey. Sorry, Mary.
No, sorry, just maybe flagging the word count topic for later discussion. I know I haven't read our report from last year, but I thought we discussed that a lot, and but yeah, maybe just placeholder to. I think my always reaction is we don't want people wasting their brain cells too much on word counts versus telling the story. But yeah, I'm having flashbacks to we probably wrote this up last year, but maybe we can revisit later. I meant to say, first of all, thank you, Andy and Mary. Very great presentation. Definitely still sinking in, but yeah, very much appreciate the presentation.
Thanks, Corey.
Yeah. Sorry, I was looking for a link and not being a good moderator here. Just throwing a link in the chat. This is from the public comments, just to add on. It's part of the Ocean Conservancy and Ecosystem NGOs fan club of the ESR, where they had put together a tip sheet or their own executive summary of the thing. Just thought it was also handy and good to see.
And
right.
we work closely with them to produce that tip sheet. So
great.
so yeah, so it's we sort of we make sure that it's on the same message and we're all on the same talking points and same sort of synopsis of things. So yeah, their tip sheet is actually really good. I highly encourage people to take a look at that.
Excellent. Great. All right. Not seeing any more hands. Stall here for just in case folks are being shy. If not, I guess I'll thank Andrew and Mary again and all the team who worked on this. I think it's another fabulous report, and looking forward to discussing it with them in person next week. So if anyone else has any more questions, feel free to reach out. And if you reach out to me, I'll pass comments on to them. Otherwise, contact them. I believe their contact information is in the document, so you can ask them directly. Go ahead, Yvonne.
Pardon me for interrupting. I just wanted to make sure that this is formally an all hands briefing, but if the EWG wants to, if there's anyone else in the EWG who has things they particularly want us to remember, then let's talk about them, make sure we quickly cover them. And then there's a lot of people on this call. If there's anyone else who wants to, from another advisory body, who wants to speak up and remind their own members of things that they might want to remember for their reports, then let's just make sure people have a chance to coordinate, if you don't mind.
Yeah, definitely. And during our March meeting, EWG will be having more discussion on this. So our meetings are open. I guess all advisory body meetings are open. So I would invite folks who might have questions to come there as well. And happy to facilitate this in any way we can. And what Andrew just said in the chat. So again, if anyone has any comments, bring them up. Otherwise, I think we'll break for 5 minutes so I can go get a glass of water, and then we'll kind of transition into the EWG planning discussion for the March meeting. So thanks again, everyone. 5-minute break, and then we'll be back. You're welcome to stay on the call and listen to the EWG ramble about what we do, or we will see a lot of you next week.
And I will go ahead and stop recording. I can